In this video, we're going to look at using trigonometry to find the hypotenuse. We use the same steps as before for finding a length. So in that, what we were doing was we were drawing the triangle, we were labelling the sides, and then we were choosing which trig ratio was going to be, so, ka, or tua. Then we substituted in the values, and then we solved the equation. So in this, we're going to do the same idea, only what we'll have to do is multiply up by the denominator and then divide by the value of the trig term. Now remember, the hypotenuse is the longest side, so in these questions, whenever we're trying to find the hypotenuse, if the answer is not bigger than the side that we know, then we've made a mistake. So in these examples, find the lengths marked with the letters in these triangles. So we've got our triangle drawn. What we need to do is label the sides. So the side opposite the right angle is called the hypotenuse. The side opposite to the angle is the opposite. And then the one beside the angle is the adjacent. Here we're trying to find the hypotenuse and we know the opposite, so the adjacent is the one that we don't care about. So whenever we write out so, ka, and tua, we need to get rid of the ones that have an A, so we can remove ka and we can get rid of tua as well. So means the sine of angle is equal to the opposite over the hypotenuse. So then sine 29 equals 5 over x. And whenever we're finding the hypotenuse, the x is on the bottom. So whenever we press sine 29 on a calculator, if we work to at least 4 decimal places, we get 0.48481 is equal to 5 over x. So now if we multiply up by the denominator, so multiply up by x, we'll get 0.48481x equals 5, and we can divide through by 0.48481, and we get that x equals 10.31 centimetres. And 10.3 is bigger than 5, so we've passed that check. In the second example then, we've got our triangle drawn, we need to label the sides. So the side opposite the right angle is the hypotenuse, the one opposite to the angle is the opposite, and the one beside the angle is the adjacent. Now we want to find the adjacent, and we know the opposite, so the one we don't care about is the hypotenuse. So we can write out so, ka, and tua, and we want to get rid of the ones that have an h in them. So we'll get rid of so, we'll get rid of ka, and we're left with tua, and tua means the tan of angle equals the opposite divided by the adjacent. So if we fill the information in, we've got the tan of 33 equals the opposite, which is 3.6, over the adjacent, which is y. Now, this is called finding the hypotenuse, and although we're not trying to find the hypotenuse in this case, the unknown is the term in the bottom, the denominator of the fraction. So that's what we're doing here. So we need to work out tan of 33, and we get 0.64941 equals 3.6 over y. So we multiply up by the denominator, and we get 0.64941 y equals 3.6, and then we have to divide by 0.64941, and we get that y is equal to 5.54 meters.